This video is an introduction to trigonometry. Trigonometry is about ratios of side lengths in a triangle based on angles. Here is some basic terminology. In a right-angled triangle, the longest side is always called the hypotenuse, and the two shorter sides are called the legs of a right-angled triangle. If we mark one of these two angles with a Greek alphabet theta, then the leg that does not touch theta is called the opposite side to theta, and the leg that touches theta is called the adjacent side. On the other hand, if it were this angle marked as theta, then this side will become the opposite side to this theta, and this will become the adjacent side to the theta. The first trigonometric function that I want to introduce is sine of theta. It is defined to be a ratio given by the opposite side divided by the hypotenuse. It is quite easy to remember. First, sine of theta is always less than or equal to 1. And by putting hypotenuse in the denominator, we guarantee that this fraction cannot exceed 1 because hypotenuse is the longest side. Second, the numerator of sine is the side that the angle theta sees directly, so it is the opposite side. Next, the cosine of theta is given by the ratio adjacent side over the hypotenuse. Once again, cosine theta has to be less than or equal to 1, so we will put hypotenuse in the denominator. And the only other choice is adjacent side in the numerator. As for tangent, tangent of a theta is actually equal to the slope of the hypotenuse. The slope is given by the rise over the run, as we all know. And rise will be the same as the opposite side. And the run is given by the adjacent side. We can also see that this is the same as sine theta over cosine theta, because if you take the ratio between sine theta and cosine theta, the hypotenuse will get cancelled, and we have opposite over adjacent as a result. Let's look at some classical examples of right-angled triangles. If we have a right-angled isosceles triangle, then these two angles are of size 45 degrees, or in radian measure, pi over 4. The ratio of these two legs is 1 to 1, and if we use the Pythagorean theorem, we can calculate that the side length of the hypotenuse is square root of 2. From the definition of trigonometric functions, we have sine of pi over 4 equals to 1 over square root 2. And we can rationalize the denominator to get root 2 over 2. Cosine of pi over 4 is 1 over root 2, which is also root 2 over 2. As for tangent of pi over 4, it is given by 1 over 1. So the answer is simply 1. This also agrees with the fact that the straight line y equals to x has the slope equal to 1, and the angle here is 45 degrees or pi over 4. Next, we have two congruent triangles with different orientation. The smaller angle here is of size 30 degrees, or in radian measure, pi over 6. And the larger angle here is of size 60 degrees, or in radian measure, pi over 3. So this angle is pi over 6, and this angle is of size pi over 3. If we duplicate these two triangles, then this angle also have size pi over 6. And combining them, we will have double of pi over 6, which is pi over 3. Together with pi over 3 and pi over 3, we found that this is an equilateral triangle. Hence, if this leg has length 1, then this will be length 2. As a result, this is also length 2 because this is an equilateral triangle. With the help of Pythagorean theorem, we can find that this has length root 3. After finding all these ratios of side lengths, we can easily compute the trigonometric values of these angles. From this triangle, we can see that sine pi over 6 is given by 1 over 2. Cosine pi over 6 is given by root 3 over 2. And tangent pi over 6 is given by 1 over root 3. And after rationalizing the denominator, we get root 3 over 3. From this triangle, we get sine pi over 3 as root 3 over 2. Cosine pi over 3 as 1 over 2. And tangent pi over 3 is root 3 over 1, or simply root 3. Apart from normal right-angled triangles, we would also like to take a look at some degenerated right-angled triangles. By that, we mean that if the angle is going to 0, then basically these two sides collapse and this becomes length 0. At that moment, these two should have ratio 1 to 1. Similarly, if this is going to pi over 2, then this will turn into 0, and the ratio between these two sides will also become 1 to 1. So if we pretend that the measure of this angle is actually 0, and the measure of this angle is actually pi over 2, then sine of 0 will be 0 over 1, which is 0. Cosine of 0 is 1 over 1, which is 1. Tangent of 0 is 0 over 1, which is 0. And sine pi over 2 is equal to 1 over 1, which is 1. Cosine pi over 2 is equal to 0 over 1, which is 0. As for tangent pi over 2, we will get 1 over 0, which is undefined. This table has a summary of what we have for the trigonometric functions on special angles. Here is an interesting phenomenon. If you look at the first row, you can imagine that all the denominator are actually 2. As for the numerator, you have square root of 0, square root of 1, square root of 2, square root of 3, and square root of 4. Root 4 is actually 2, so 2 over 2 gives us 1. Cosine is exactly the reverse of the first row. As for tangent, of course, it is the first row divided by the second row, because tangent theta is equal to sine theta over cosine theta. So we have 0, 1 over root 3, 1, root 3, and undefined. Finally, we would like to mention that the reciprocal of trigonometric functions are also quite useful, and we would like to give them explicit names. 1 over sine theta is called cosecant of theta. 1 over cosine theta is called secant of theta. 1 over tangent theta is called cotangent theta. Notice that in each of these three identities, we have exactly one co between the two. So this one does not have a co, and this one has to have a co. This one has a co, and this one does not have a co. This one does not have a co, and this one has a co. Hence, 1 over sine theta cannot be secant theta. We have to put a co-secant theta there. By the way, what is co? Co actually stands for complementary angles. Complementary angles means that those angles add up to form 90 degrees or add up to form pi over 2. Hence, what is cosine of theta? Cosine theta actually is the same as sine of the complementary angle pi over 2 minus theta. What is cosecant of theta? Cosecant of theta is actually equal to secant of the complementary angle. As for cotangent theta, of course, it is equal to tangent of the complementary angle. All of these can be verified by drawing the right-angled triangle. If we denote this as theta, then this will be pi over 2 minus theta, and they are complementary angles. Now, for example, if we look at cosine theta, then it will be adjacent over the hypotenuse. But you can also think of this as the opposite side to the complementary angle over the hypotenuse, which is sine of the complementary angle. Thank you very much for watching this video. If you like it, please subscribe to our channel, and we will learn more fun math together. Thank you.